In this video on integration by parts, I'm going to show you how to find the integral we see here. And if you're up for it, go ahead and press pause and try and find this integral before I show the solution. Either way, let's get started. I'll just move this to the side, like so. When given an integral to find, like this one, I like to give it a name. And for that, I won't be particularly original. I'll go ahead and call this integral capital I for integral. So capital I is equal to the integral of 3x squared times ln of 5x. Now looking at the integrand we have here, that's the expression we're trying to integrate, we can see that we are trying to integrate a product of two functions. Indeed, we have 3x squared, which is multiplying ln of 5x. And when integrating a product of two functions analytically, remember we only really have two options. One of them being the method of substitution, the other being integration by parts, for which I've reminded us of the formula in the upper right hand corner of the screen. Now when using this formula, the important thing to figure out is which of the two functions in the product we call u dash of x, and which one we call v of x. And a nice rule that I'll illustrate right now is that when we're dealing with a product of a polynomial function, like 3x squared, and a simple ln function, like this ln of 5x, then the quickest way to integrate this using integration by parts is to call the ln function v of x and the polynomial function u dash of x. And in fact, I should be more specific. When I say a simple ln function, I mean any ln function looking like ln of some number a times x. Okay, now back to this integral. We're therefore saying that u dash of x, or u prime of x, equals to 3x squared, and that v of x is equal to ln of 5x. Consequently, u of x will be equal to x cubed, and v dash, or v prime of x, will be equal to 1 over x. And if ever you're surprised that this v dash of x doesn't have a 5 on the denominator or even on the numerator, then it's worth making a note of the fact that as soon as we differentiate a simple ln function like this, ln of ax, its derivative will always be equal to 1 over x. And if you need some convincing for this result, go ahead and use the chain rule to derive it. You'll quickly see that the derivative of ln of ax will always equal to 1 over x. That being said, I carry on. Using the right-hand side of the integration by parts formula and replacing u, and v dash by their respective expressions, we can go ahead and state that this integral I is equal to u times v, so that's x cubed times ln of 5x, and I'll just write that, that's x cubed times ln of 5x, minus the integral of u times v dash. So that's x cubed times 1 over x. And again, I'll quickly write that. That's x cubed times 1 over x. Now, looking at the integrand we have here, we have x cubed times 1 over x, which will quickly turn into x squared. And so I becomes x cubed times ln of 5x minus the integral of x squared. Finally, taking care of this integral, we can state that I, the integral we started off with, is equal to x cubed times ln of 5x minus 1/3 of x cubed plus some constant of integration c. And that's the final answer. We've just used integration by parts to find the integral of 3x squared times ln of 5x. And there we go. That's it for this tutorial.